Container D has a base area of 650 and was filled with oil up to a height of 29 cm. They said that the water flowed out of a tap in D to E, which had a base area of 400 cm squared. So is this number reflected inside here? And is this number reflected here? It's not, right? If it's not, go and put it inside your own diagram to help yourself. So area for D would be 650 cm square, and the area for E would be 400 cm square. So I'm going to put here area 400 cm square. After this, then proceed. They say that the tap was turned off immediately when the height of the oil in container E was twice the height of the oil left in container D. They asked what was the volume of oil in container E in the end. Now, this is an advanced version of the previous question. Remember the previous question in the previous video, we are always doing the, hey, you know what, we have to stop flowing or like stop pouring water in when the water level is the same. Now this one is telling you that the oil level here is twice of this. If it's twice, how do you do? Let me teach you this method. Now imagine that there is another container E. I'm going to try my best to draw the same size and same dimension as this container E. Please don't mock at my drawing. Okay, this one is another container E. I'm going to call this container F. Okay, container F and container E, right, both of them has the same area. Basically, right, I am just saying that there is another container E, which is this. Now, if the water level here is 2 times of this one, if the oil level here is 2 times of this one, and if I take this one and then I divide it by 2, I pour half inside here, wouldn't the oil level now for all three be the same? So it will be the same, right? Which means that what do I need to do in order to find the volume of oil in container E in the end? Okay, I will have to find the total volume of oil. Then I will need to add up all the area. This area plus this area plus this area. I add them all up together. I take the volume of oil inside here. I divide by all this area. Once I divide by all this area, I will be able to find the amount, the height of the oil for each of them. And it must be the same. Once it's the same, right, I pour this one back inside here. I'll be able to get the answer of the volume of oil in container E in the end. Okay, so this is a new method that I'm not sure whether your school taught you, but this is actually one of the ways that you can do it. Now, so the first step we need to do is to find the total volume of oil over here. So I'm going to put here total volume of oil in D, and that will be area, the base area multiplied by the height. So that will be 650 multiplied by 29. Okay, so throw that inside calculator, 650 multiplied by 29, and that will give us 18,850 cm cube. Okay, now I'm going to find the total area. Total area would be 650 plus 400 plus 400. So it's 650 plus 2 times 400. Okay, so let's see, 650 plus 400 plus 400 would be 800, right? So 650 plus 800, and that will give me 1450 cm squared. Now, I will take the total volume of oil divided by total area to find the height for each of them, which will be the same. So height would be this divided by this, 18850 divided by 1450. So let's try to calculate this. 18850 divided by 1450, and that will give me 13 cm. Okay, which means that each of them over here, right, the oil level in each of them after you pour from D to E and then E half to F will be 13 cm. Okay, now this container F is something that you created by yourself, so they are not looking for a container E when half of it is poured into container F. They are looking for a container E with the full amount. So since I already poured half inside here and then it's 13 and 13, right, which means that if I pour this one back inside here, this will be 13 times 2, which is 26. So the total height here will be 26 cm. Okay, so they're asking for what is the volume of oil in container E in the end. You will just have to take the base area multiplied by the height of the oil. Okay, so volume of oil in container E will be 400 multiplied by 26. So 400 multiplied by 26, let's just calculate it with the calculator, and that will give us 10,400 cm cube. Okay, so for this method, right, is actually a little bit more flexible. What if the next question they're asking for is the height of the oil in container A was 3 times. What if it's 3 times? Then draw 3 lah. Okay, what if it's 4 times? Then draw 4 lah. Okay, it's not that difficult, like. Okay, do you really need to draw the shape of the cube? Not really. If you do not draw the shape of the cube, then just draw a rectangle. Doesn't matter. It's perfectly fine. Do not worry about it. So this method can be used for questions when they are asking you to compare the height of the liquid after it has been poured out. Whether the height of the liquid is the same, or whether the height of the liquid is 2 times, or 3 times, or 4 times. This method can work. Alright, done.